This module will help you understand transmission fluid and its function inside the transmission. In the first lesson, we'll follow the flow of transmission fluid from the pan through the internal circuits, and in the second lesson, we will cover the ingredients of transmission fluid. Finally, we will cover the different formulations and specifications in lessons 3 and 4. To understand why using the correct transmission fluid is necessary, you first have to know the transmission fluid flows inside an automatic transmission. The journey starts in the pan. The transmission fluid is drawn from the pan through a filter by the pump that is behind the torque converter. The fluid level in the pan and the transmission body is critical. Too little and the transmission will suck air into the pump. Too much, well, the fluid will become in contact with the rotating components of the transmission. Both scenarios lead to aeration of the transmission fluid. Air or bubbles in the transmission fluid can be bad for the performance of the transmission because air can be compressed. Fluid can't be compressed. Air in the system can prevent solenoids, check valves, and actuators from engaging clutch packs, bands, and even some of the drums. It can even prevent the torque converter from engaging the transmission and shifting gears. This is basic hydraulics. The pump first generates a suction force that draws fluid into the chamber of the pump and is eventually compressed on the other side with considerable pressure. Cavitation occurs when changes in pressure lower the temperature which the transmission fluid changes from a liquid into a vapor. These small, low-pressure zones can occur around high turbulence areas. Common areas include the vanes of the pump and the blades of the torque converter turbine, impeller, and stator. Those bubbles you see are not air bubbles. They are small vapor pockets of gases that can be damaging to the fluid and the surfaces of the transmission. So, what is the connection between fluid quality and cavitation? Fresh transmission fluid has additives that control the temperature where the fluid transitions into a vapor. The change is damaging to the fluid and causes oxidation. After the pump, the fluid comes to a valve that does two things. First, it controls the line pressure to the valve body and other components. On most transmissions, the line pressure must remain constant, even though the input and output speeds change as the solenoids open and close. To keep the correct line pressure, the fluid must have the correct weight or viscosity. Second, the pressure regulator valve will direct the fluid to the components like the valve body, torque converter, gears, and even servos. It will also direct some of the fluid into the thermostatically controlled cooler circuit. The temperature of the fluid is critical to the operation of the transmission. Keeping the fluid in a specific range requires a thermostat and a way to transfer the heat to the outside air. There are a couple ways to do this. Most late model transmissions will have a thermostat that will allow cold fluid to bypass the cooler. As the fluid heats up, the bypass will close and force the transmission fluid into the cooler circuit that will be connected to either an air oil or a water oil heat exchanger. Some modern transmissions include a warmer that uses engine coolant to heat the transmission fluid when it's cold. This has two benefits. First, it reduces startup emissions by decreasing the parasitic losses of pumping cold transmission fluid. Second, warm transmission fluid reduces wear inside the transmission. The most important thing to remember about thermostats and coolers is that the circuit can hold a considerable amount of fluid or air. This is critical that when the final fluid level is set, the transmission is warm. For most transmissions, the first stop after the pressure regulator is the torque converter. For the torque converter to work, the stator, turbine, and impeller must be submerged in fluid. If there is any air inside the body of the torque converter, the efficiency of the turbines and the impeller is compromised, and the vehicle might not move, or the fluid can become aerated or even foamy. Air inside the torque converter will also cause excessive heat due to cavitation. On most late model transmissions, the fluid inside the torque converter lubricates the friction materials and the surfaces of the clutches that control lockup. In addition, the fluid travels through the turbine and output shaft to lubricate the clutch packs, shafts, and planetary gears. The pressure regulator valve also supplies consistent line pressure to the valve body. The valve body is nothing more than a series of valves, solenoids, and accumulators that are connected to servos that engage the clutch packs and apply bands to control the planetary and sun gears of the transmission. Hydraulic components need clean fluid of the correct viscosity to control the input and output of the transmission. If the fluid is not correct or it's worn out, it can cause the valves to leak, stick, and cause slipping and even harsh shifts. Transmission fluid may stay in the passages of the valve body and servos and eventually be cycled through the relief ports. Some circuits in the turbine and output shafts carry heat away to lubricate the friction surfaces, but it will ultimately end up in the pan and the fluid will be cycled through the transmission again and again. Keep in mind, a transmission is a sealed system. What contaminates transmission fluid is high temperatures that oxidize the fluid and break down the raw ingredients. Eventually, this leads to damaged components inside the transmission that we'll discuss more in depth in the next lesson.